Question number 7. This question is about silicon and compounds of silicon. If you look into the periodic table, you'll find that silicon is group 4 element. Just like carbon, I can think about it as if it is a giant covalent substance. First part says the reactivity series sometimes includes non-metals such as carbon, hydrogen, and silicon. So before I carry on, I need to remind myself what do I mean by word reactivity series. So it's a series of different elements and it shows the reactivity. So if I have a reactivity series here, as I go down, the reactivity decreases. It says silicon can be extracted by reducing silicon dioxide with different substances. So they are saying reducing silicon dioxide. What does the reducing means here? Reducing means it will gain electrons. They've given us the equation. 2 carbons will react with silicon dioxide, which is 1 mole, and will produce 1 atom of silicon and 2 moles of carbon monoxide gas. If you pay attention to this equation, this is basically displacement reaction. I can see here that carbon has displaced silicon from silicon dioxide, and that shows that carbon is more reactive than silicon. The question says explain what this reaction shows about the position of silicon in the reactivity series. So you'll say silicon will be below carbon. It is below carbon. In other words, I can say less reactive. Why am I saying this? Because carbon displaced silicon from silicon dioxide. I'm going to say because carbon displaced silicon. Next part of the question says aluminium also reduces silicon dioxide. Again, an important statement telling us that aluminium is also more reactive than silicon. Carbon is used rather than aluminium to reduce silicon dioxide because carbon is cheaper than aluminium. Carbon can be obtained by heating coal. Aluminium is obtained from aluminium oxide. So remind yourself, extraction of aluminium from its ore is through electrolysis. It says explain why aluminium is more expensive than carbon. So it is more expensive because number one, it is extracted using electrolysis. Number two, the process uses a lot of energy. And that's why it is expensive. Next part says magnesium also reduces silicon dioxide. So again, they're telling even magnesium is also more reactive than silicon. The equation for the reaction is shown. So you have to make sure you pay attention whenever you see these equations. So you can see here, it is solid and solid on the reactant side. So both reactants are in the form of solid. On the product side, they are also solids. So if you look at the previous equation here, one of the product was gas. It will be easier for us to separate silicon from the products because one of the products is gases, so we don't have to worry about it. But in this case, both products are solids. So if they are both solids, it will be a bit difficult to separate silicon from magnesium oxide. So it's give one reason why products are difficult to separate. All I have to say is both products are solid. So pay attention to this. Next part says calculate the minimum mass in grams of magnesium needed to completely reduce 1.2 kilograms of silicon dioxide. So basically, you'll have to make use of this equation. So what I'm going to do is I'm going to copy this equation. The equation is 2 mg plus SiO2, and this produces Si plus 2mg. Before I start working on this equation, I have to make sure that I understand this equation. That this equation is telling me that 2 moles of magnesium will react with 1 mole of silicon dioxide to produce 1 mole of silicon and 2 moles of magnesium oxide. So in terms of moles, I can write down this is 2, this is 1, this is 1, and this is 2. Now I'll check again what the question says. It says calculate the minimum mass in grams of magnesium needed. So it is about this: to completely reduce 1.2 kilograms of silicon dioxide. So I don't have to consider my products. I only have to focus on my reactant side. Once I have figured this bit out, I'm going to convert these moles into masses. So I'm going to do mass, and we know moles can be converted into mass by multiplying it by, here I'll say AR, here I'll say MR. So the AR of magnesium, which is relative atomic mass, is given to us as 24. So if I do 2 times 24, it will change to 48. When it comes to silicon dioxide, I'll have to add 28 plus 16 and 16 together, and that gives me 60. Now, these are my masses. As long as they have same unit, it doesn't make any difference. So I can say here, this is 48 grams and this is 60 grams. So in other words, I'm saying, as per the information given in the equation, 48 grams will require 60 grams of silicon dioxide. Now the question here says, calculate the minimum mass in grams of magnesium. So this means we do not know the value of mass for magnesium. So I can say X grams will react with, to completely reduce 1.2 kg of silicon dioxide. So I can't use in kg because I'm using grams here. So I'll have to do 1.2 times 5,000, which is 1200 grams. Once you've done this, then this can be answered. You cross multiply them and equate. So you'll multiply 48 times by 1200 equals 60 times X. And if you divide both sides by 60 now, this will cancel out, leaving you with X being equal to 960 grams. And this is my answer. So this question is about reacting masses. And this is how we solve these type of questions. Next part says Si2H6 is a covalent compound of silicon and hydrogen. So it's a covalent compound. This means there will be sharing of electrons. This is what's going to happen in this case. It says complete figure 9 to show the outer shell electrons in a molecule of Si2H6. So I'll have to make a key first. So I'm going to say hydrogen is being represented by a cross, whereas Si electrons are being represented by a dot. So I know each hydrogen will need 2 electrons for it to have a complete outermost shell. So I can say there'll be 2 of them here, 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 2 of them here. We know that silicon has 4 electrons in the outer shell. How do we know this? Because it's a group 411. So out of these 4 electrons, 1, 2, and 3 are being shared with hydrogen. There is 1 left for the left silicon, and same applies to the right silicon. So there will be another 1. And this completes the diagram for this. Next part says Si2H6 reacts with oxygen. The equation for the reaction is 2Si2H6 gas plus 7O2, 4SiO2, and 6H2O gas. It says 30 centimeter cube of Si2H6 is reacted with 150 centimeter cube in excess of oxygen. Now this is important. So we are using oxygen in excess. This means some oxygen will be left to once the reaction reaches completion. It says calculate the total volume of gases present after the reaction. What does this statement mean? This means they're saying you have to work out total volume of gas. Now the total volume of gas on completion. it will be comprised of two sections. One will be leftover oxygen plus 6H2O. This is also in the form of gas. So I'm going to say plus amount of water produced. If we can work out these two values, then this means we'll be able to work out the answer. So for this question, again, I'll have to copy the equation. The equation says 2Si2H6 gas will react with 7O2 gas again. This produces 4SiO2 solid plus 6H2O gas. Now you have to remind yourself about one more thing, that the volume ratio is same as mole ratio. Volume ratio is same as mole ratio. So as per the equation I can see here, I can write down my moles. My equation tells me that 2 moles of this compound react with 7 moles of oxygen to produce 4 moles of SiO2 and 6 moles of H2. Now, out of this information that is given to us, 30 centimeter cube of Si2H6, this is my limiting reagent. So the amount of products produced will depend on this. So let's first figure out how many centimeter cube of oxygen will be consumed by 30 centimeter cube. I can write down here, this is based on equation, this is based on question. So in question it says you have 30 centimeter cubes of this, and we do not know this, so I'm going to call it X. Then we can use this and we can cross multiply and solve. You'll end up with 2 times X equals 30 times 7. You divide both sides by 2. You end up with X being equal to 105 centimeter cube. So this tells us that this is the amount of oxygen that will react with 30 centimeter cube. So from here I can work out leftover O2 will be 150 minus 105, and that leaves me with 45 centimeter cube. So I've done the first part, this one. Now the next bit is we need to figure out the amount of water produced. For the amount of water produced, what I'm going to do is I'm going to use this and this section. So the amount of water produced we do not know. I can call that Y. And I'll do the same thing. So it will, this time it will be 2 and 6, 30 and 1. So can you cross multiply them? You will end up with 2y equals 30 times 6. We divide both sides by 2 and we'll end up with y being equal to 90 centimeter cube. This is the volume of water or steam produced. So the total volume will be 45 add 90, and that gives you 135 centimeter